Okay, 11.3 is area of polygons. Area of polygons. So one of the polygons that you've already learned about area for would be area of a triangle. So area of a triangle is 1/2 base times height, or sometimes you see the equation written like this, base times height divided by 2, which you've been working with for quite a while. In this lesson, we're going to look at triangles, but we're also going to look at, sorry, I'll go back to this in a second, shapes like this that are more abstract, like hexagons or octagons or septagons. But these are essentially all made up of triangles, so you could just use the equation of a triangle to get part of that shape and then multiply it by however many triangles there are. So that's one of the ideas in this lesson. And then the other thing, we're going to start out with area of a kite or a rhombus. Now for a kite of a rhombus, they're made up of triangles. So technically you could just find the area of each of these triangles. So you could do base times height of the triangle, like 6 times 10 to get 60, divide that by 2, get 30. 6 times 10 is 60, divide that by 2 to get 30. 6 times 2 would be 12, divide by 2 to get 6. And 2 times 6 is 12, divide that by 2 to get 6. And then you can add up these areas, and the area would be 60 plus 6 would be 72 units squared. So that's one way to find the area of that shape. But there's also a shortcut way where we can use an equation. So for the area of a rhombus or kite, we can use this equation. Area equals diagonal 1 times diagonal 2 divided by 2. So D stands for diagonal. So for example, with number 1, the length of this diagonal is 38 and the length of this diagonal is 19. So diagonal 1 times diagonal 2 and then divide by 2. This comes out to 722 divided by 2. The area of this shape is 361 units squared. So technically you could find the area of each of those triangles if you wanted to, but this is a little bit simpler. The only thing is this equation's not on the reference sheet, so if you're going to use it, you have to remember it. And if you don't remember the equation, you can always just find the area of each triangle and find the area that the shape that way. So for number 2, even though we already solved it using the triangles, if we use the diagonals, it would be 12 times 12 and then divide by 2. So 144 divided by 2 would again be 72 units squared. Okay, number 3, diagonal here shows that this is 7 plus 7, so that would be 14 all the way across. So one diagonal is 14. The other diagonal right here, 5 plus 5 is 10. So to find the area of the shape, just 14 times 10 divided by 2 equals 70 units squared. Okay, number 4 is a little bit different. It shows the diagonal here is 6, but it doesn't show the length of this diagonal here. But it is a rhombus. We can see that all the sides are the same. So therefore, these intersect at a 90-degree angle. And we have right triangles. So if this whole thing is 6, then this part right here would be 3 and 3. And then we can use this little right triangle right here and find the length of this side using Pythagorean theorem. So we're going to just use a squared plus b squared equals c squared to find this length. So 3 squared plus b squared equals 5 squared. can we get 4? And then if this is 4, then this is 4 over here. And now you're looking at the length of your diagonals. So this would be 6 and 8. So be 6 times 8 and then divide by 2. 48 divided by 2 equals 24 units squared. Okay, and then for this portion, it's talking about some vocabulary. It has an inscribed polygon in a circle. It asks you to identify the center of polygon JKLMN. So JKLMN is this pentagon here. The center right here is at point P. Here it says identify the central angle of the polygon. Well, central angle, I would say it's right here from the center to to the vertices. So angle MPN would be a central angle. And then as far as the degree measure of that central angle, so for pentagon there would be 5 of these central angles. You can do 360 divided by 5 is 72 degrees. And so angle MPN is 72 degrees. Okay, and then number 7, what is the radius of this polygon? So radius is a distance from the center to vertex, any vertex. A vertex is the corner. So a radius would be like PM right here. So segment PM, and the length of that is 5 units. And then a new word that you haven't seen before, an apothem. Apothem is apothem, yeah. Center to the side of the polygon. So for example, from the center P to the side right here, PQ would be an apothem. And then the length of that, it says, is 4.05. Okay. Then in the next section, it says find the measure of a central angle of a regular polygon with a given number of sides. Regular polygon means all the sides and angles are the same. So if you have a 10-sided regular polygon, you can just do 360 divided by 10 sides and you'll get each central angle. So that would be 36 degrees for 18 sides. That comes out to 20 degrees. 15 degrees, 7 sides, 51.4 degrees. Then on the back, ready, set, flip, the back. Okay, next, on the back. Okay, so for 13 through 16, find the given angle measures for regular octagon A, B, C, D, E, F, G, H. Okay, so here is our shape. It says it's an octagon, so that means it has 8 sides. It's regular, so all the sides and angles are the same. It wants to know the measure of GJH. So measure of GJH. Not her. Okay, well, it looks like that is one section of that octagon. So we can do 360 divided by 8. And so GJH is 45 degrees. Then it asks for GJK. So tracing, it would be this little angle right here, like so. Half of the one that we just found that this whole thing is 45. It shows this altitude here, meaning it bisects the angle. So we can just do 45 divided by 2, which is 22.5 degrees, and that's GJK right there. Then we got KGJ, which would be right here. So this triangle right here is a right triangle. I'm going to just kind of sketch it out. It has a 90-degree angle here. We just found that this angle is 22.5, and then we're trying to find this angle. Well, the way to find that, or one way we could find that, is 180 minus 90 minus 22.5. Since it is a triangle, these angles will add up to 180, and that gives us 67.5 for that angle. Okay, and then number 16, EJH. So EJH right here. This happens to be 1, 2, 3 sections of the octagon. So if each section is 45 degrees, we can multiply that by 3 to find that angle, and it is 135 degrees. I'm trying to see if it's on here or no. Okay, next concept. We're not going to do every piece of it because it would take us a while. We're going to do 17, and then I'll go over the concepts for 18, 19, 20. So for 17, it shows a triangle. Normally you would need base times height for that triangle. What I'm going to show you that you can do is you can actually break up this triangle into 3 separate triangles. Okay, it says these are regular polygons, so we have the base right here, like all the sides would be the same. So this is 12, and then the height of this triangle is 2 square root of 3. So we can find the area of just this triangle and then multiply it by 3 to find the total area. So area of a triangle is base times height divided by 2. So area of one of the triangles, the base would be 12, the height is 2 square root of 3 divided by 2. And if you solve this out in a calculator, so the area of one of the triangles would be 20.78. And then to find the area of the whole shape, you could just multiply that by 3. So area of all of them would be 20.78 times 3. So area of all would be 62.35. Okay, I'm trying to figure out how to simplify some of this to make it make sense. Okay, I'm going to use a pencil. So on 19, again, I'm not going to go through all the steps, but I think a lot of you are at a point, if I explain the concepts, like if you saw that problem, you could figure it out. So here it's showing one triangle right here, and there's actually like 2 triangles that make up that section. So it's 1, 2, 3, 4, 5, 6, 7-sided shape, and there's actually 7 like central triangles. And then each one of those triangles can be broken up into 2 with an altitude. So essentially there are 14 triangles that go all the way around, 14 triangles, 14 right triangles. And if you found the area of one of the right triangles, you could just multiply that by 14. And this here is saying that the altitude is 2.5 and the hypotenuse is 2.77. So you could use Pythagorean theorem to find this missing part, find the area of this triangle, and then multiply that by 14. I think I did it at some point over here, but I'm not going to have you write all that down. But yes, you can find the length of this, then find the area of one triangle, then multiply that by 14 to get the area of the whole thing. This one over here is about the same thing. Let's see. Actually, this is almost exactly the same thing, except they give you the whole length here, which you'd have to divide by 2 to get just this part. But then it would be the same thing. Find the area of one triangle, then multiply it by however many triangles you have. This comes up in another lesson too, so you will get to practice it, but just kind of looking at the concept. For number 20, it's even more complicated because they don't give you the apothem length or anything like that. But you could use the angles and trigonometry to find a missing side. But again, it's Friday, and I don't think we're up for all that. But that's how you could do it. Okay, we're going to stop here. I'm going to give you time to do your homework. Recording.